So here we have two functions, y equals to positive square root of x plus 2 and y equals to minus square root of x plus 2. Okay. And but because of the restricted domain and range, so let's draw it. The range, okay, let me show you using graphic calculator, but you should be able to do it by hand. Okay, because I did do a tutorial on how to sketch square root functions. Okay, so what do I do is let's sketch them. Okay, okay. Okay. Now let's input the function. So I will have x plus 2. Okay, I put them in bracket, power of half. Okay, and let me put it in the graph. So okay, this is the graph of this is the graph of y equals to positive square root of x plus 2, and well, okay, and let's sketch y equals to minus square root of x plus 2. Okay, if I have x plus 2, let's say I draw this one in the dotted line. Okay, okay, I can't. Okay, oh yeah, here. Okay, you see the graph underneath is our second graph. Okay, it's the graph of y equals to minus square root x plus 2, because in the from our calculation with interchange x and y, we find the range. Okay, the range of the inverse graph is from 0 to positive infinity. Okay, now so as we can say, the second graph is not relevant because the range of the second graph is from 0 from minus infinity to 0. Okay, so okay, this is not our solution. We only have one solution there. Okay, so because the range is from 0 to positive infinity, so the equation of inverse fx would be square root of x plus 2, positive square root of x plus 2, and the domain is from minus 2 to infinity. Okay, which is we found out from interchanging x and y. Okay, okay, this is your okay. the domain is the range of the original graph here, original equation, I say. Okay, so what do I do is I have to sketch this graph there. Okay, it will be something like this. Okay, and as you can see, I have one x-intercept and one y-intercept. So f minus x equals to okay. So this is how do we sketch an inverse function. Okay, the okay the domain of an inverse function is very important. Okay, I will do some more examples, but okay, this is minus 2, this is square root of 2. Okay, now I'm going to tell you some more properties of inverse function. Okay, let's read from the graph. Okay, okay, the basic principles of inverse function is to interchange x and y. As a result of interchanging x and y, what's happen is the domain of the original function becomes the range of the inverse function. The range of the original function becomes the domain of the inverse function. Also, the x-intercepts of the original function becomes the y-intercepts of the inverse function. Also, the y-intercepts of the original function becomes the x-intercepts of the inverse function. So, in other words, if I have a point in I just say this point, they have the similar values, they have the same value, because of the interchange between x and y. Okay, and also if I have point here, the coordinate, or say the coordinate of this point A is say the coordinate of this point, say the point P, okay, is A and B. Okay, when it is reflected, okay, when it is reflected on the line y equals to x, okay, the equivalent point, the inverse point P, which will be there, so I just label it there, Q, would have a coordinate B and A. Okay, because we interchange x and y, so the in any point of inverse graph, inverse function and its original function, the coordinate also, the x coordinate also becomes the y coordinates on the inverse graph. The y coordinates on the original graph also became the x coordinate on the inverse graph. Okay, this is all because the interchange between x and y. Okay. Okay, now